Hey folks, in this lesson we're going to practice some more factoring of polynomials, but we're also going to use factoring to solve polynomial equations. So before we get started solving these equations, we can tell how many solutions there will be at the end. The number of solutions is going to be the same as the degree of the polynomial. So if I look at this first equation that we can solve, I see that the polynomial on the right is a degree 2. Remember, the degree of the polynomial is the highest exponent. So because this is a degree 2, this will have 2 solutions. Those solutions could be real, imaginary, or a combination of the two. In our second equation, that polynomial on the right has a degree 3. 3 is the biggest exponent that I can see, which means that this equation would have 3 solutions. This is something you can keep in mind when checking your work to make sure that you've found all of the solutions that exist. So we're going to solve by factoring in each of these cases. So first we're going to practice factoring with a greatest common factor, a GCF. So I'm going to do the one on the left, and I'm going to have you try the one on the right. So on the left, I see my polynomial has 3 terms, and all of those terms have an x in common. They all have a factor of x. So I'm going to divide that x out in front. When I do that, I'm left with x squared plus 2x minus 15. In the parentheses, I see a trinomial that I can factor further. This is a quadratic. I'm looking for 2 numbers that multiply to negative 15 and add to a positive 2. They are positive 5 and negative 3. So my parentheses breaks down even further into x plus 5 and x minus 3. I can't forget the GCF from the first round of factoring. I'm going to drop that down, and I have 3 factors: x plus 5, and x minus 3. Now, if this had just said factor, we'd be done now. But since it's a factor and solve, I'm going to find my solutions by setting each of these factors equal to 0. And then I'm going to solve for x. My first factor is already solved for me. My first solution is 0. In my second factor, I'm going to subtract 5 from both sides of that equation and get a second solution of negative 5. And in my last one, I'm going to add 3 to both sides. I get my third solution of 3. So my solutions are negative 5, 0, and 3. You can list them separately, or you can put them in one list. And when I check back with my polynomial, I'm glad I found 3 solutions since this was a 3rd degree polynomial. I want you to pause the video, try the one on the right, and press play when you're ready to check your answer. All right, for the one on the right, we started with a GCF of 4. When I divided that out in front, I was left with x squared minus 25, which I can factor further. That is a difference of squares. X squared minus 25 factors down into x plus 5 and x minus 5. Setting all 3 of those factors equal to 0 makes me first think that there'll be 3 solutions, but that first factor doesn't give me a solution. 4 equals 0 doesn't make sense. 4 doesn't equal 0, so there's no solution from that first factor. From the second and third factors, I get a solution of negative 5 and positive 5. So we end up with 2 solutions, which matches the fact that our polynomial was a 2nd degree polynomial. Next up, we have factor by grouping. So we're going to factor as much as possible and then solve by setting each factor equal to 0. So starting with this one on the left, we factor by grouping by breaking down our polynomial into 2 groups of 2, and then we're going to GCF each half. So on the left half, I have a greatest common factor of x squared. When we divide that out in front, we're left with x plus 3. On the right half, between negative 8x and negative 24, there's a GCF of negative 8. Dividing that out in front, we're left with another x plus 3. Now, if we're factoring this correctly, our parentheses should match. Our next round is to GCF the polynomial as a whole. That matching factor of x plus 3 goes in front. Our original GCFs, x squared and negative 8, form the second factor. I can't factor either of those further. So once I've done that, and I've factored as much as possible, I'm going to find my solutions by setting each parentheses equal to 0 and solving for x. In my first parentheses, that equation there, I need to subtract 3 from both sides. I get a solution of negative 3. In my second equation here, I would add 8 and then take the square root of both sides. When I do that, I get 2 solutions. I have to remember that both the positive and negative root are a solution. Square root of 8 simplifies into 2 square roots of 2, and I end up with 3 total solutions. I have 1 from the first factor, negative 3, and 2 from the second factor, positive 2 root 2 and negative 2 root 2. I want you to pause the video and give the next one a go. Press play when you're ready to check your answers. All right, so in this last one, we start by factor by grouping, chopping it into 2 groups, taking the GCF of each half, and then GCF again. We should find that our factors are x minus 2 and 2x squared plus 8. When I set each of those equal to 0 to solve for x, I find that that first parentheses gives me a real solution at positive 2. But when I set the second factor equal to 0, I get the square root of a negative, which means that I have an imaginary solution. I get plus or minus the square root of negative 4, which simplifies to plus or minus 2i. So I have a total of 3 solutions. 2 of them are imaginary, 1 of them is real. Our last factoring method is the quadratic pattern, and this is where there's no greatest common factor other than 1, and I only have 3 terms, so I cannot factor by grouping. Okay, we're going to look for our patterns of 2 numbers that multiply to the end and add to the middle. So in this first case, those 2 numbers are 6 and 1. Just like we saw in the previous lesson, when we create our 2 parentheses, each of them is going to begin with an x squared, since our original polynomial was x to the 4th power. One of those factors fills in with a positive 6, and one fills in with a positive 1. Solving for where this function is equal to 0, where that polynomial is equal to 0, means I'm going to take each of those parentheses and set them equal to 0 and get x by itself. Okay, in that first parentheses, when I set it equal to 0, I'd subtract 6 and take the square root. I get plus or minus the square root of negative 6, so I'm going to get 2 imaginary solutions. Taking out the square root of negative 1 as I, this simplifies to plus or minus I times the square root of 6. I'm going to find that I get more imaginary solutions from that second equation. Subtracting 1 from each side gives me x squared is equal to negative 1. When I take the square root of both sides, I get plus or minus the square root of negative 1, which is plus or minus I. So all 4 of my solutions are imaginary this time, no real solutions. I want you to try the next one on your own. Pause the video, give it a go, and press play when you're ready to check your answer. For this last one here, our quadratic patterns give us factors of x squared minus 9 and x squared plus 5. X squared minus 9 can factor further. It's a difference of squares. So we get 3 factors, x plus 3, x minus 3, and x squared plus 5. Our first 2 factors give us real solutions of negative 3 and positive 3. Our last factor gives us 2 imaginary solutions of positive and negative I times the square root of 5.